Hello everyone. Welcome to this week's edition of CamLogic's Tech Tuesday. My name is Rob Carver and I am an applications engineer here at CamLogic. Tech Tuesday is our free weekly 30-minute tips and tricks webinar. Today's topic is working with the Helix. But first, let's familiarize everyone with CamLogic. CamLogic has been in the CAD/CAM CAE space for over 35 years. The company was established 16 years ago, initially focused on CAM, servicing mainly the tool and die shops in the area. As the market has evolved, CamLogic has evolved. Interestingly, working our way backward from manufacturing to the conception of the idea or design. Because we started toward the end of the process and worked our way to the beginning, CamLogic has the fundamental knowledge of what has to be done to assure that each step of the process will result in a product that will actually work or fit into the next phase of development. CamLogic has chosen to represent software and tools that enable our customers to fulfill the full cycle of product development. We consider ourselves integrators and partners for our customers, not just resellers. CamLogic employs a three-legged stool strategy. We partner with Siemens, offering the complete integrated Siemens portfolio for design, machining, analysis, and data storage and retrieval. We partner with 3D Systems for 3D printing and rapid prototyping, and Steinbeckler, white and blue light scanners, and Creaform for 3D scanning for inspection and quality. Now that you've heard a bit about CamLogic, let's move on to today's topic, working with the Helix. Maybe you have a unique thread form to create that doesn't fall under the thread function. Or perhaps you want to create a coil or compression spring. The Helix command allows you to create a wide variety of helical shapes to which you can then apply geometry. Today's focus is going to be on how to create a Helix, the menu options, and how they work in possible applications. For you experienced users out there, there might be nothing new here. However, for users new to NX, you might just see the solution or spark an idea as to how to solve a problem you're struggling with. That is, after all, the whole idea behind our tips and tricks segment. And with that, let's see how this works. And, okay. So, basically, when you go in to create a helix, you go into the Insert Curve Helix function. Okay. Now, these two lines I'm going to use here in a little bit, but basically, your starting function, the first thing you're going to want to do is set your coordinate system. The Helix function operates off your WCS. So I'm just going to accept this position, my WCS here. Okay, and it remembers the last options that you had selected. Okay, so we can go down through here, set the angle, the orientation angle. So grab this little node here. Okay, and I can change where the orientation angle, where that helix starts or stops. Okay, it actually just starts. That's just the starting angle. Okay, or you can type in an angle if you want to type in 180 degrees or whatever. Okay, in this case, I'm just going to leave it at 0. The next side, you can either go with the diameter or the radius. If you want to input a radius on it, okay, that 0.5 obviously becomes larger. Let's leave it at radius. Okay. You get a couple of different options here. Constant radius is pretty apparent. Linear allows you to put a start value and an end value in. Okay. So if I'm going to say 0.25 here at the end value, I can get like a tapered helix going here. You might use that to create a valve spring or a tapered coil spring or something of that sort. Okay. that's under linear. Okay, my constant, or my pitch would be next. And again, you've got the constant option, and this is the distance between the loops. Okay, I can vary that to say maybe 0.25, or I can vary it 1. Give myself a nice coil like that. Okay. So I mean, this is where you change your pitch. Now, to limit this, you can either do by limits or by turns. Okay, if I've got, in this case, it saw that I had a 0.1 pitch, and it just automatically put 10 turns in there. But you can put 4 turns, okay, and then govern the length of your helix by the number of turns in the pitch, okay. If I put 24 in there, obviously, I'm going to get a much larger spring, okay. Going back to our pitch for a second, that also has linear or cubic, linear long spine. Let's do the let's play with this linear long spine for a second. Go back to a constant pitch here, my 187. Okay, and we'll go back to limits. I had it set up as 1. Let's go 2 just for fun. Something strange about a person that says he has fun playing with the helix here. Anyway, if I wanted to change, let's explore this linear long spine for a second. Okay, what this allows me to do is vary the diameter along a spine. That's what the function of these 2 lines out here are. I can pick this one. Okay, and the position, the length of the lines are totally irrelevant. It doesn't really matter. I've just got these out here this long just for illustrative purposes. But the position or the length of the lines really is immaterial. Okay. So now in this case, move this over. I've got 0.1 here. I've got 0.1 here, and my dimension and the relative position on this spine. Okay. If I select a new location, here's my position. I notice it filled in a number 1 there. Let me go back and put that 0.5 back in. Okay. See how that changes. Okay. And now as I move this, as I move my point or my node along that line, see how my helix changes. Okay. Or vice versa, if I go this way, you get a totally different shape. Okay. Now, if I wanted to add another node in here, say one there, one there. Okay. Now I'll go in and edit this. Let's go, just for grins, let's go 1.25 here. Okay. And on this one, let's go 0.75. Let's go smaller. Oops. I got too many decimal points here. Okay. 0.75. And I still have too many decimal points. Hang on. We'll get rid of it. There we go. All right. And I can move that along this way. All right. Let's make that even smaller. Ooh, that's small. So you can see as you get along, the more points you add, the more control you have over this. Now there's also law functions that you can apply to it. I'm not going to do that this morning. But you can see the degree of control that you would have over the radius of your point. Okay. Let's remove that one. Move this one. And you know what? Let's remove that one too. So now we're back just to a couple of points here that we can get some control on. Now we can also do that same thing with our pitch. If we go linear along a spine. Now the difference between cubic and linear, it's not really going to be real apparent here. Linear is just, if you can imagine, say, like a sine, envision a sine wave, where the peaks and are very, very close together. The linear is going to give you a nice straight variation along the peaks, whereas cubic is going to give you a more gradual curve along that line. Okay. But anyway, I kind of got off my track a little bit. So let's go back to linear along a spine. Again, I'm going to select this spine. Select my endpoint, okay, and my pitch at this point is 0.25. Okay, maybe I want that 1.25. Okay, I'm going to select a new location here. This one I'm going to leave it. I'm going to leave that one at. I'll make that 1.25 too. Okay, now we'll go in and select a couple more positions. This one. Let me make that, let me make it dramatically larger, okay? And I'll select another one over here. Okay. All right. Let me put it back just so you guys can see what's going on here. All right, you see how my pitch is changing as my diameter is staying the same, but my pitch changes as I move my node along this line. Okay, and then I can change the diameter here along this line. Okay. Change my orientation, so you can see the kind of control that I've got over the shape. And that's pretty much all I'm going to show on this portion. Possible applications. Let me open up another file here. Now let me use the window. I have it open here already. Okay. Nice pretty picture. Looks like a filler cap. Okay, in this case, this thread form doesn't necessarily fall under the thread function. Okay, so let me kind of step through a little bit how I did this. I'll hide my revolve for the time being. Just show my thread form. Basically, I've got, I'll hide this, hide my datum plane, okay. So basically, start out with a helix. Actually, I started out with this helix. Make this my current feature. Started out with a helix. And again, let me get it back here so we can see it. There we go. Whoop, I'm getting dizzy here. I hope nobody else is. My coordinate system, my helix is based on my coordinate system. Okay, so I had selected my coordinate system. I just used a linear with a start value of 875 and end value of 1. I've got my setting to radius. My pitch was a constant, very simple, 1.25. And I did a turn setting, and this time I only did like a 0.95. I didn't want a complete turn on this, okay? So my next helix was a constant radius of 1 inch, and again my pitch was I set to a 0.25. Okay, number of turns was 4, right hand, and then I did a bridge curve between the two. Okay, one thing I failed to mention is I had moved my WCS for this second helix. I moved my WCS up a 1/4 inch. Okay. Then I did a sketch. I'll make that my current feature. I did a quick little sketch here on the path of this helix, and then I did a swept. Okay. And from this point on, it's just a matter of, you know, I created this little revolve here, unite the two, add a couple more, add a handle to it, and I've got my revolve. Oh, there it is. I gotta show it up here. Okay, and there's that's basically the steps I use to create that filler cap. Okay. I'll open up another quick file just to show you an application. Perhaps you need to create something a little bit more like this. This is a gear hob. Okay. As you can see, I've got a couple of sketches here that I use to create my shapes with. But the main thing I wanted to show you is I used a helix. Again, use the same basic function where I had a helix. I created a sketch on the path. In this case, I really scaled up my my tooth profile when I had to follow that helix around there. Now, the one thing about doing that type of thing is you have to make sure that your orientation when you do your swept. Okay. Let's make that the current feature. Where did it go? There it is. I'm going to make that my current feature. Okay. Okay. Come down, when you go into your sweep like this, you want to make sure that you specify vector on your orientation method. Okay. And in this case, I use that line, or that line of the sketch is my orientation method. Okay. And then I really scaled up my the size of my sketch by a factor of 5 to make it fit there. Okay. When I did the sketch initially, you know, I just pulled it in. I pulled it in from my reuse library. It was for another application. And rather than just, you know, redrawing my sketch, it was the shape I wanted. I just scaled it up. Okay. And again, I created it on that path rather than on a plane. Okay. And that pretty much concludes this portion of my demonstration. Well, I should mention that I did some synchronous modeling to get rid of some of this. See how this is this would be wrapping around. So I got some partial teeth here. So I did some pretty cool synchronous modeling, just deleted a few faces off in there to clean my geometry up. Okay. So with that, I will conclude this portion of my demonstration. Go back to my PowerPoint. And, you know, we can't emphasize enough the importance of training to get the most out of today's technology. You know, the training would allow, you know, a person hunting and pecking around for, you know, the functions, the different, you know, how do you do this, how do you do that? You know, that all costs time and money, and it's well documented that training helps improve the speed of use. It increases efficiency. It provides for faster problem solving and leads to fewer support calls, all of which positively affect your company's productivity, your return on your investment, and the bottom line. At CamLogic, we offer a wide variety of hands-on, instruction-intensive courses for users at every level. Training is available at the on-site location of your choice or at one of our training facilities, training labs located throughout the Midwest. And for more information or to register, please visit our website. Today's webinar can be found on YouTube, usually within 24 hours of the broadcast. Check out CamLogic on YouTube for past webinars as well. And thank you for joining us today. If you have any questions, please feel free to email me or call me at any time. Be sure to visit our website at www.camlogic.com. We can also be found on LinkedIn, Blogger, Facebook, YouTube, and Twitter. This concludes today's edition of Tech Tuesday. Thanks again for tuning in, and have a great day.